All right, hello, this is your video for your Unit 1 quiz review. So I got this document camera to have at my house so I could record videos while I'm at home, and it's really blurry unless I'm super zoomed in. So I'm sorry that it's so zoomed in, but we're gonna persevere. All right, so the first one says, draw a graph that has a hole at x equals 1. So, there's a lot of different things that you could draw, but at 1, you have to have a hole. So I would be as simple as possible. There's no need to make it more complicated, just something like that. All right, and then we're going to state limits from the left, from the right, and overall. So here I'm really just checking your notation, that you know the correct notation. So we're going to approach 1 from the left for this function. We're going to approach 1 from the right of this function. And then we're going to approach 1 not sided, just overall for this function. So I guess I need to kind of put some tick marks on my y-axis. And again, this doesn't really matter, but I'm going to make this be at 2 there. So the limit from the left, the limit from the right, and the overall limit are all going to be 2. It doesn't matter that there's a hole there. A limit is just behavior. So these are all 2. The graph is not continuous, but continuity is a totally different thing. We're just talking about limits right now, and it's just the behavior of the graph. So number 2, we're going to draw a graph that has a jump discontinuity at 0. And again, you want to be as simple as possible with this. Don't make it any more complicated than it needs to be. So again, I'm just going to do something linear. So we'll have it look like that. So we want a jump at x equals 0. And then we're going to do the exact same thing. So we're going to limit x goes to 0 from the left of the function, limit x goes to 0 from the right of the function, and limit x goes to 0 overall, so not sided. So these are going to be different. From the left, I made this graph approach 2. From the right, I made it approach -1. And so the overall limit does not exist. If you were to zoom in at 0, there's no overall behavior. Not like this one where both sides come to the same place. It's a jump. It's literally broken. So does not exist for the overall one. All right, for this one, we're going to draw a graph that does all of these things. All right, so we're going to try and put all this information into a graph. Limit as x approaches 2 from the right is infinity. So that means I know at 2, we're going to need to have a vertical asymptote. So I'm going to dot that in. And it says 2 from the right is infinity, and 2 from the left is -infinity. So I don't know where else this is going yet, but I just put little arrows in there to remind myself. So right side goes up, left side goes down. The limit as x approaches infinity is 4. So let me put my tick marks up to 4. Approaching infinity, we're going to level off at 4. So actually, I'm probably going to need to put this arrow a little higher up so that I can make that fit. So let me just put that a little higher there. All right, limit as x approaches -infinity is -2. So I want the left side of my graph to level out at -2. And then last thing, the limit as x approaches 0 is -3. So I need this to come all the way down here to -3, but I'm putting a hole because it says the limit as we go to 0 is -3, but the actual point at 0, f of 0, is 1. So the actual point is going to be up here at 1. So that's like the haha, I tricked you, the point's over here now. And then I'm going to kind of just connect everything else and make it level off at the asymptotes that I drew in. So again, you're just taking all that information and putting it together into a graph. So I'm really just checking your vocabulary there and that you know what all those words mean. Number 4, state why the graph, that should say state why the graph of number 3, sorry about that, is discontinuous at 2. Use correct notation. So at 2, we are missing a point. Your first part of your definition of continuity is that there has to be a point, and f of 2 does not exist. It's the easiest way to say it. And so again, this should say number 3. So state why that graph is discontinuous at 0. So at 0, we have a point, we have a limit, both sides come together here, but they don't equal each other. This is the one that's a little bit harder to write. We're going to say limit as x goes to 0 of the function doesn't equal the point at 0. So you have a point and you have a limit, but they're not equal. The point is up there at 1 and the limit is down there at -3. All right, piecewise function. What is the value of k that makes the function continuous? First thing we're going to need to do is factor and cancel out here. So this is going to split x minus 3, x plus 1. And so our x plus 1s are going to cancel. If we want this to be continuous, we're going to set the two parts equal. So I'm going to have x minus 3 equals x plus 5k. And then we're going to plug in -1 for x. So if I plug in -1 for x over here, that's going to give us -4. And over here, it'll be -1 plus 5k. And then last step, we're just going to solve it. So if you add over the 1, that's going to give you -3. And then divide by 5. So -3/5 is what we get there. So we factored and canceled out. We set the two parts equal because we want it to be continuous at -1. So then we plugged in -1 for x and did a little bit of algebra there. All right. Solving limits algebraically. So we don't have a graph. First thing you always want to do is try to plug in the number. So if we plug in -1 here, that's going to give us -4 plus 1, which I guess would be -3. I guess I can just go ahead and write -3, huh? So that'll be -3 over 0. That means that there is an asymptote. And so we're going to test whether this goes up or down. So -3 is a negative number, just, is. And then we're going to test the denominator. We want to go to -1 from the left. So if you pick a number to the left of -1, like -2, if you plug -2 into this, you're going to get a negative result. And a negative number divided by a negative number is a positive number. So positive infinity is our answer. All right, this one is going to involve a good bit of algebra first before we can get anywhere. If we plug in 4, we're going to get 36 minus 36 on the top and 4 minus 4 on the bottom. So we're going to get 0 over 0. First thing I'm going to do is multiply this out. If you can do this in your head, that's cool. If not, just go ahead and write it twice, and we're going to multiply that all together. So x times x is x squared. Outsides are 2x, insides are 2x. So together that's 4x. And then 2 times 2 is 4, but I'm going to subtract 36. So I'm going to just go ahead and put those together so I don't have to recopy everything in another step. So 4 minus 36 be -32. And then over x minus 4. Next step, and I see how I'm writing limit every time. Technically, you do have to put that. If you get a right answer, I'm going to mark it correct. But on the AP exam, if it's free response, you have to put limit notation there, or they will not give you credit. So this is going to split +8 minus 4. We get these to cancel. 0 over 0 means there's a hole in the graph, so we're canceling out the part that made the hole. And then you plug 4 back in. So 4 plus 8 is 12. So our overall answer to the whole thing is 12. Right here, I'm going to just try and plug in -2 and see what happens. That's going to give us 4 minus 8 minus 5. And on the denominator, that'll give us 4 minus 1, which is 3. So let's see what that all shakes out to. 4 minus 8 will be -4 minus 5 will be -9 over 3. And so that reduces down to -3. All right, here I'm going to try and plug in 3. In the numerator, that will give us 7. On the denominator, that's going to give us 0. So just like the one right above it, it means there's an asymptote. But unlike the one above it, it's not sided. And so we can't plug in a number from the left or from the right to test. And so it's going to just be does not exist. If it's not sided and you have an asymptote, automatically it's just going to be does not exist. All right, this is one of those fun little graphs that we looked at in class. Answer is either going to be 1 or -1. If you notice, this is from the left, so I know it's going to be -1. If it was from the right, it would be +1. But if you do need a picture, it would look like this. Over here at -7, your graph is going to do something like this at +1 and -1. But if you want, you don't have to draw that on your quiz. If you just want to remember, from the left, it's going to be -1, and from the right, it's going to be +1. That's how those look. All right, if we plug in 2 here, we're going to get square root of 16, which is 4. -4 is 0. Denominator will also be 0. So we're going to have to do some algebra, and we multiply by the conjugate. So we're going to multiply that on the numerator and the denominator. And the point of that is it makes the root cancel out. So if you do square root of x plus 14 times square root of x plus 14, you just get x plus 14. The outsides and the insides are going to cancel because one's positive and one's negative. That's kind of the whole point. And then -4 times +4 is -16. The denominator, I'm going to just leave alone. If you start trying to multiply that all together, it is going to look awful. Like if you start to try and do that, you are going to go, oh, whoops, this cannot be right, because it's going to just look like a complete mess. So just don't do anything with that. Now we want something to cancel out, and it does. X plus 14 minus 16 is x minus 2. So these cancel. Numerator goes to 1. And for the denominator, we're going to plug 2 into this. So you get square root of 16, which is 4, plus 4 is 8. So 1/8. And then last one, this is your natural log graph that's been shifted to the left 5. So at -5, there's going to be this asymptote, and the graph is going to do something like that. So it's your ln graph, but just shifted left 5. And if you go to -5 from the right, and it's good it's from the right because you can't go from the left, there's nothing over there, the graph is going to -infinity. But again, if you want to, like if you can picture that graph in your mind, you don't have to draw it on your quiz. You just know it's going to be going to -infinity. You just can put the answer.